known is Citrix virtualization, stuff like that. So the agenda is to kind of tell you what Splunk is, because I'm sure that's probably the biggest question in your mind. We're obviously, I had actually just a conversation with Sasha just a second ago on it's really hard to explain what Splunk does to people, because normally they approach Splunk with a specific thing in mind. But I'm going to try to explain what we do and how we do what we do, and hopefully it'll make more sense. And then we're going to do some demos. One of the first questions we always get asked is what is Splunk? And where did the name Splunk come from? It comes from spelunking, basically to go dig deep into caves and explore. That's kind of where we come from. So they just dropped E and kind of went from there. They probably weren't thinking about Europe when they came up with Splunking, because we've had actually Cisco Live one year, actually in London, they dropped the L in the like telling people what we did, and I was sitting at the booth, and the guy is kind of giggling off to the side, and he goes, "What exactly do you do?" And I'm like, "What do you mean? We do data stuff." He's like, and then he pointed at it, instead of saying Splunk, it said Spunk. So he was like, it was a very funny thing. But what's important about this particular slide, and what I hope will make sense to you, is our vision statement. So Splunk's vision statement is to make machine data accessible, usable, and valuable to everyone. So we're going to go through each one of those components and kind of explain that. I will ask you to bear with me. This will start off kind of slow, and it won't make a lot of sense to begin with. But in the end, it'll make a lot more sense. So just kind of bear with me. It will make more sense as we go. So the easiest way the way I try to explain, so I kind of have this like 5-minute spiel, actually not even 5 minutes, but like 1 minute, 60-second spiel when I'm at conferences and stuff like that, and people come up like, so what is Splunk? So the easiest way to explain Splunk, as far as the way I'm concerned, is basically made up of real kind of 3 different components. And these 3 components together make a platform. The primary component, or what most people kind of think about us, is the indexing. So we're a data engine. So you can send any kind of textual data you want to Splunk. It doesn't matter what it is, doesn't matter where it came from. It can be anywhere from server logs to oil rig data. Doesn't make a difference. If it's textual data, you can send it in Splunk. We're going to take that data and we're going to store it exactly like it's sent to us in a map-reduced index that can be on 1 server or 1,000 servers. The more servers you throw at it, the faster it gets. So on top, that's the kind of the indexing thing. That kind of doesn't provide a lot of value just in itself, right? Because we can store the data. Getting the data, this doesn't seem to be a big problem for people. Like there's 1,000 different ways to get data. It's making that data accessible. And now how do we do that? We do the accessible thing by taking it to the next level, which is making it searchable. So if we make the data searchable, now we're kind of getting to that next tier of accessible. So what I can do is I can search that data again from one index to 1,000 index. It doesn't matter. I'll make that data accessible for you. The cool thing about first of all, our search language is really powerful. You can search a lot of different things, and then we have a lot of different, like you can do statistical analysis, you can do math, and there's a lot of other kind of correlations, transactions. You can do a lot of, our search language is actually quite complex in what it can do, but it's really powerful. But the kind of the coolest thing is that we do field extractions at search time. So remember when I said we store the data. We don't touch that data, we don't chop it up, we don't put in a relational database, we don't do anything like that. The data comes in. If it's a syslog message, the syslog message will go into the index. If it's a file that we're tailing, that part of the file will just go into the index. If it's a script that you ran, whatever you ran will be put into the index, just like it was done. So you never lose context. You never lose that data points. It's always there. The field extraction, or the stuff that kind of makes it have like a relational feel, is the field extraction at search time. So stuff that lets me say, hey, give me all the events for a user named Joe, or give me all the events from computer, my Yeti Mac, which is the name of my computer, right? That field extraction happens at search time. And I'm going to show you all this stuff in a second. I'll show you kind of how we do that. But that happens at search. So it doesn't actually happen until you bring up the search bar and start typing, right? So that's the accessible part of it. So again, that's great, but not everyone likes to see. Like, no one wants to look at just text all day long, right? So just because I can search it and I bring back a bunch of records, probably not going to be all that useful for you. The way we make that valuable is by giving you visualizations, right? So we can take that data, those searches, and convert them into pie charts and line graphs and all that kind of good stuff, right? So when we went back to the very beginning, the first part is we do data consumption. We can get data from pretty much anywhere. We can do log files, config files. We can do S&P alerts. We can do database. We have a S&P engine that will let you consume that. We have data. If you want to actually pull the data from a database, a SQL database, we have a DB Connect to let you connect to a database. You can run scripts. Our Zen app, our Zen desktop, our NetScaler apps, all of those basically run a script, and the script collects the data and then posts it to Splunk. This is just kind of one of those really noisy slides, so I don't expect you to read it all right now. But you'll have this will give you some ideas of where data can come from. Any amount, any location, any source, doesn't matter. We don't. The other thing, good, is because the data extraction or the relative feeling of the data doesn't happen until search. Since it doesn't happen until search, I don't have to worry about schemas. Right? The biggest problem with most monitoring products, right? It's a specific vertical, but one of the biggest problems with monitoring products today is they've kind of got to know the questions that you want to answer before they design their database, right? Because they have to store the values to make those answers in the database. Because they have to chop up the data, they got to put it in the database. We don't have to do that. So if there's we don't have to know the question beforehand. We can always figure that out later. And it can be done. A good example I use of this is like domain name. So if you're a smaller company, just one little shop, let's take AppSense, right? They started off with one product. And so they don't care about AppSense domain/username, right? They just want to know the username. But as they buy more companies like, more data, what is data? My brain just froze. And they bought Data Now, sorry. They bought Data Now, right? That's a different domain, right? And in between the migrations, you might have Joe user and Data Now, and you may have a user in AppSense now, the same name in both, right? So later on, right now, I don't care about the domain. Later, in the future, I may care about the domain. So I can extract those based on that, and I can do that at search time. And all the data that I've stored, that search is still valid. I haven't had to change anything. I didn't have to wipe out my database. I didn't have to go, oh crap, got to do a schema change, and oh, is this schema change going to break what I just did before, and all that kind of stuff. We don't have to worry about any of that. We don't have any no custom connectors. You can create a connector is not the same thing as a collector, which you'll hear us say a lot. A collector is just basically a script or a piece of code that sits on a machine and forwards data to Splunk. A connector is I have this database over here and this database over here, and I have to connect them using some kind of data manipulation to convert from this schema to this schema, effectively, right? We don't have to worry about that, again, because we just deal with text. We don't care what it looks like. We provide the structure at search time. No RDMS, so we don't worry about relational databases. We don't have to worry about any of that stuff. And again, no schemas, all that kind of good stuff. No need to filter or forward the data. We can do all the filtering later on, so you don't have to forward it from one component to another component to let it do processing. Like you do processing and send the data to me, so you don't have to have those hops in the middle. So far, I'm going to break all of, again, I want to break all of Alex's rules, so feel free to interrupt me if you have any questions. This is somewhat interactive. I don't mind. I have plans for that. Not a whole bunch, and I'll control. I won't let you go crazy. Like if you start asking me what my kids' names and ages are, we can ask about that later. But if you have any Splunk-related questions, I'd be more than glad to answer them now. So what I'm going to do now is I'm going to show you a demo, because I like to do demos mostly. Let me, did that switch? It didn't switch, and that's because stupid. It doesn't like my screen swapping. There we go. You can see that, yeah? Nope. Yeah, there we go. Anyway, so when you first pull up Splunk, this is what it looks like. Just looks like a search bar. And it's got, down here you'll see what we call sources, right? And then you'll have counts, last update. Actually, when we receive the data, we store the raw data in the index, but we do actually index for specific fields, which is the host name, source type, and date time, like when the event actually happened. So you'll see that here. And then up here is the search bar. So let's just do a real quick search. So when we do a search, we want to do stuff like index equals. You want to kind of narrow it down. In this case, and if you just look at this first screen right here, it kind of gives you some start points, right? It'll tell you what host that you have. You can do source types, and up there at the top, it'll tell you what kind of sources we have. If you wanted to, like say you just like, I want to see what running processes I have, I can just click that. And it'll take me into a search that already has that up there. So it'll do source equals perf mine equals running processes. And probably shouldn't do all the time. So let's do this. Let's do this too. We'll do index equals Uber agents. You'll see this later. So, like when you do a search, obviously it's going to give you a bunch of data. Again, this textual data, maybe not all that valuable to begin with. But what I want to show you over here is this stuff this thing right here, which is, and you can't really see the screen's off a little bit. So if there, you'll see over here where it says there's 6 interesting fields, and then there's 3 selected fields. So basically what it's saying is, we looked at this data and we saw some things that look consistent like across the different records, stuff like time positions and time startup position. But you're also going to see this, and this all this stuff, all the fields. Yes, Sean?
Can you zoom? You have a Mac, right?
Yeah, I got a Mac. Is that better?
That's better.
All right, so anyway, haven't you seen this presentation like 20 times? Anyway, so these are the fields that it kind of said, you know what, these are fields that we see a lot in the data. And all of these fields were extracted when I did the search. Right? This isn't stored in an index, and like it didn't know these. When I pressed go on the search is when it found these. Does that make sense? Everyone understand that? It's important later on when we do this. Because this is the data, right? And there isn't any clear indication of what equals what. But it says, you know what? There's 6 interesting fields, which means I've seen these a lot, over 50% of the events, and there's 57 total fields that I've been able to extract from the data. If you want to see the fields, you can click here, and I'll show them all to you. But if you go in here, remember we talked about source types. We can break the source types down by different types. So if I want to look at like application usage, right? It'll narrow down those fields to ones that only map to that particular event. Right? So any questions on that? So, and you can also, if I wanted to see, like say I have a specific one, and I wanted to see it, I wanted to see these sources on the left here. Like I wanted them to show up here, I could just click that and it would add those to the list, or it should add them to the list. That's not everywhere, so there. It helps if you press save too. So you'll see that now on the machine. Okay. The other thing I wanted to show you, actually, let's do this one. This is my local one. Send desktop. And you'll see that this works with every kind of data. Then in this one we have 8 interesting fields with 125 unique fields. And if I wanted to narrow that down, I could say, I just want to see stuff like session data. And now, because I've narrowed it down to session data, instead of only having 6 interesting fields, I have 35 interesting fields. Because I'm narrowed down the scope of the data, there's a lot more duplicated fields. I haven't told Splunk anything. Like I didn't say these are fields. It figured it out on its own. Granted, this particular data is kind of mapped for that. So you see connected via IP equals blah. In such case, if the data isn't that easy to read, you can educate Splunk. And you can say, hey, when you see this regular expression, this is the MAC address. Or you see this regular expression, this is a switch IP or whatever you want to call it. And a lot of this stuff, we're going to have Splunk is obviously a pretty big platform. So we have a master class tomorrow where we're going to go through and we're going to set up Splunk. We're going to install some data gens because obviously I can't give you all a UCS chassis. I would like to, but everyone would show up at that point, I'm sure. But anyway, we'll go through and we're actually going to do some searches and show you how to do data extractions and all that kind of good stuff. But for the sake of the time period we have today, we can't go into that. But the third component is what I was saying before, which is allows you to visualize these things. So you can get that kind of data, those fields and those data extractions, and then convert them into graphs. Really cool looking graphs, although you can't really see these very much either. But so if you want to do something like application detail, you can see this is a table up here, but then it has pie charts and line graphs and all that kind of stuff. Now Splunk has a whole bunch of built-in controls that you can use, and you actually don't even have to be a developer. It's really just XML, and you say, and actually that's not even, you can, there's a drag and drop option too. You can actually go in there and let's do a, let me see, I'm actually going to show you this in a second, but we're going to do another demo in a second, and then when I do that, I'll show you how to do a quick search and make a dashboard out of that search. Any questions so far? I'm going fast. So, okay. So architecture. This is like from a simple Splunk architecture can be very simple to really complex depending on what you want to do with it. But even our really complex infrastructure is fairly easy to manage. In this particular case, you really have what they call an indexer. In a search server. So this is all you have. You don't have to have anything more than that. If you have a situation where your searches are getting slow or you want to have more data, you can have as many of these servers as you want, and it's as simple as putting up another server, installing Splunk, and pointing the forwarders to it, and you're done. You don't have to do any configuration. You don't have to. It's like you don't have to set up clustering. You don't have to do anything. It just kind of manages all that stuff on your own. You just have to say, you tell the search head, these are the indexers that have the data, and it will handle all the rest. Make sense? These are what we call Splunk Forwarders. These are optional. You don't have to do that. You can actually, the Splunk server can run data collection on its own, or it can have an SNMP listener or a data DB Connect. It can have syslog. It can listen for syslog messages. It can do all that. But in situations like ESX is a good example. Like if you want to get data from ESX, you don't want to install something on ESX. They won't. Well, you can, but VMware will be upset at you if you do. What you can do is you can create a small VM that does data queries against that, and then in that situation you would install what they call a Splunk Forwarder, which is a very lightweight version of Splunk that doesn't do anything but send data to Splunk if you tell it to. So when you install the Universal Forwarder, it doesn't do anything. It has config files, and that's the cool thing about Splunk, because we support all these. We support Windows, Linux, Mac, and HP Unix, and AIX. We have a large variety of platforms. The management of the application is the same. It's just basically config files. So on a Universal Forwarder, you just tell it, this is what I want you to do. I want you to go run the script, or I want you to listen, tail this log file, or I want you to listen to the Windows event logs, or whatever you want it to do. So that's what the Universal Forwarders do. Because of the way that we work, we scale to terabytes a day. And that doesn't sound like a lot, but we're talking text, right? And our largest customer to date that is published, I guess, their name's not published, but the numbers are published, is 100 terabytes a day. That isn't stored. That isn't data that's stored on file disk. That's how much data they are consuming on a daily basis and searching in real time. So it's a pretty big deal. And like I said, to be able to get that much data in real time, it's pretty spectacular. The automatic load balancing. So again, in this situation, this is where you have multiple indexers, and you have your what you do is you basically tell all your forwarders all the indexers you have, and then it'll auto load balance. So let's say you have 10,000 forwarders, and you want to have those 10,000 forwarders go to like 10 or 15 indexers. You can put all those 10 or 15 indexers on all the forwarders, and they'll just kind of randomly offset and offload those data so that your searches are fast. And you can do multiple ones, so if one indexer goes down, it'll just automatically fill over to another one. So you don't have to worry about losing data if an indexer goes down. In this case, I was telling you before, like the distributed search, so what you do is you have a single, or you can have multiple Splunk search heads. And a Splunk search head is really just a Splunk install with the indexer disabled. Right? It's still the same install. We only have two installs: the Splunk install and then the Universal Forwarder, and that's it. All the other functionality is built into the core Splunk, and you just kind of turn on and turn off features at will. And one of those features is the search head, which is the pretty visual things that we saw. The search bar and those dashboards, those are done on the search head. When a search is when you type in a search, it gets shot out to the indexers, one or many, and they return the results, and then the indexer, the search head starts processing the results as they come in. Any questions on that? No. MapReduce, does that? Y'all are pretty technical, so MapReduce is probably not a big term for you guys, but MapReduce basically, I like to explain it as like RAID for data. Like your Stripe set, not necessarily RAID 5, but you basically write the data across many servers, and then when you do a query, you send the same query to all the servers, and they all kind of start telling me their answers all at once. Does that make sense? So if I have 1,000 servers, that's 1,000 places where I can kind of thread that conversation out, or that search out, and then they can all start sending their data to me, right? So my dashboards will start populating immediately, and then they'll backfill as the data starts coming in. Does that make sense? Yep. But that's the formal definition of MapReduce. It was invented by Google, and it changed the internet. It's the way that Google is able to give you millions of results on a search within milliseconds of typing in a word. Actually, even before you're done typing the word. So. Splunk runs across data centers. Matter of fact, we have cloud offerings. You can run it in the cloud. You can run it in your data center. You can run it across multiple data centers. The way the configuration works, if you, let's say you have a branch site scenario where you have 10 branch sites, you can have an indexer in each one of the branch sites and then a central search head. Or if you're like a consultant or a managed service provider and you have multiple customers, you can have an indexer in multiple customer sites and let them have local search heads. And then you have a master search head that can search all of them at once. You can have all kinds of configuration options. It's pretty powerful in that regard. So another demo, I'm going to show you how to do some of the data extracts. I think we're doing good on time. So, should make Helga come up and do this. You're going to do it today. Isn't your session today? So let's take XenApp for example. So let's create a dashboard for XenApp. We want to look at what's a common thing? Server load. Let's do server load. So if I want to look at like the average server load by per server, I can go in here. Remember, I was just doing discovery. I know that the index is XenApp, so I can look down here and I'm like, what are the source types that I have? And obviously this is the one that looks server load, and now that's restricted my events to only server load. And then I can see over here, and I'm like, okay, well, I have farm name. I have 2 farm names. I can do load. It'll show me, also, if I do load, it'll kind of show me some of the values that it's seen, and the top part of those values. Same thing with machine name. It'll kind of show me the machine names, that kind of stuff. Server name. So if I wanted to do something like, just give me a stats command. I don't want to do caps. And let me have the average load as load by server name. And that should give me the average server load by server name. If I want to have this for multiple XenApp, like so right now this is for XenApp 6.5. If I want to do it for 6.0 and 6.5, I can do that. The other thing is again, we're agnostic. We don't care what hypervisor, we don't care what you're using. We can collect from XenApp 5.0 all the way to XenDesktop 7. We do all the XenDesktops, all in the same interface, all with the data, all in the same spot without having to have different infrastructure for each. So that's our server load. Now, if I wanted to do something like I want to make it, what would be good? What kind of chart would this be good for? I don't know. Let's just look. Which ones look good? Gauge obviously doesn't look all that useful. We can do line chart. And these are the server names. Nope, that's not very good. Do area. This is in Amazon in the US, so it's a little slow. And the Wi-Fi is not spectacular either. I should have switched to the... yeah, but Alex refuses to give me the password. I must look like a shady guy. So I can't give it to Brandon. He'll share it. Come on. Anyone got a MiFi? This is horrible. Anyway, it's normally like super fast. Oh, let me do this. Let me. I think I have. This is my local instance, so I don't know that I have XenApp data though. Yeah, I don't have any XenApp data. I have XenDesktop. What's something in XenDesktop we want to look at? I have XenDesktop data right here. Let's do sessions by user. How about that? So it wasn't light. It is fast when you're local. I have a. That way. There we only get 10 people. You can still see that, Sean? I had to make it a little smaller. They all have 0. This is Jason's data gen for you. Let's do this. So that'll be the max number of sessions. Oh, you know what? I was picking the wrong. The problem with that one is that I was picking a field that didn't exist. It's session ID. Session UID. So distinct. That's a distinct count of session UID. There we go. So what this does is this means distinct count. You can do average, you can do sum, you can do max, min, all that kind of stuff. Session ID is a unique identifier established to every session because we don't want to get duplicate sessions, right? That's not useful. I want to know how many unique sessions the user had. And I want to call it, like if I didn't do this, it would just call it session ID. I would call it session UID. In this case, I want to say, you know what? It's not that. It's sessions, and then by username. And then I can do pretty line graphs by username. Let's do head again. Sort descending just says, you know, I only want the bottom or the top. Yep. And there we go. Head 10. Oh, sorry. And head's only going to give me the top 10 or top set of them. And then obviously I don't like that, so I want to do, you can do an array graph. I can do a bar graph. That looks better. Yes, this guy's got 2.75. No. It's actually 3, but it's just funny. And you can control the axes. You can do pie, like a pie chart if you prefer pie charts. Scatter, which is not, for this particular data is not good. Radial graph, not good in that case. But it's the bar one looked good. And then if I want to make this into a dashboard, I can just do save search. Or I'm sorry, I just want to create dashboard panel. I'm going to call this cool stuff. New dashboard. I'm going to be my overtime demo. You can do keep, like if you want to be the only one that sees the dashboard, you can do keep dashboard private. If you want to share it to everyone but read only so they can't change it but look at it, you can. You can actually give everyone access to change it too, but you wouldn't do that here. We call this panel, and we're going to call this you can tell it to run the search every time it runs. You can actually have this scheduled too. So if you want the dashboard to come up immediately with the data, you can say, you know, run this. I want this search to happen every 10 minutes or every 5 minutes or every hour, and then it'll just show you the last results that it has. And actually, Now if I want to see that dashboard, I can do this. If I want to edit it, I can just click here, and then I can edit it and say, oh, you know what, I don't know that I really like the bar graph. I decided I really wanted to do a column instead, and I want to do stack mode, then I can change it on the fly. Now if I want to go back to my search and do something else, what's another interesting Zen desktop thingy? Let's just do total sessions. So Zen desktop, source type. And notice it's down here at the bottom, it's kind of filling it in for me. And then it's kind of giving me some ideas of what you might want to do. So it'll give me all the sessions. And then maybe I just want the like the total sum of total number of users. So I can do user name by, actually I want values by. That'll show me let's actually reverse that. Let's do if I want to know this session UID by username. So before it showed me how many I had, this will tell me the actual session IDs. Like so, and I would want to put that in a table. I can actually create a dashboard panel for that. Oh, actually, no, sorry. I want to put that on existing dashboard. So I can say new dashboard or put it on existing dashboard. So if I want to put this panel on the dashboard I just created, I can just put it down here. And then I'll call the panel sessions by user ID, and I'm going to use table. And then I can go back and view that demo. And there it is on the bottom. And then if I wanted to add something else, I'm trying to think index equals Zen desktop. Source. So I want to do my sessions. Actually, let's do this instead. Let's do a time chart. This will give my sessions over time. And instead of doing and you can do real time. You can do real time with different windows. I can do 1 hour, 30 minute, all that kind of stuff. This is actually going to do and then this one maybe we want like a, I like the line graph. What do you area graph maybe? All right, let's go. You can just pick the dashboard I want. So if I got that, I'm like, you know what? I really don't like that. I really prefer to have this dude down here next to the guy up at the top. I can do them side by side. And I'm like, I'd rather have that first. and then I can do so off, and then it's done.
And now export this to a file that you can reuse at another customer?
Oh, so this is cool. So this is the dashboard. This is the XML. So if you put this XML at your customer, as long as they have the same data, you're good. I mean, outside of that, you can. I mean, you can actually just go. Again, all of this stuff is just config files. So, like, if you just want to go to the folder and get the XML, you can do that too. But it's however you want to do. That's how you could view the XML. Again, there's like a lot of other stuff we can do, but we only have a few more minutes left. So, and I don't even know if I'm even halfway through the slideshow yet. It's all Axe's fault for not telling me to take questions. No. Apps. So I kind of talked about Splunk as like all the different components of Splunk, and I just kind of showed you how to put all those dashboards together. All of that together is what we call a Splunk app. I hate the term app, but they don't ask me these things. But it's what they call it. It's a Splunk app. All a Splunk app is, so if you go to Splunk Base, which is where kind of our app store, as it were, if you go there, you'll see a Splunk app for Zen app, a Splunk app for Zen desktop, a Splunk app for Uber agent, right? You'll see all these apps. All those apps are a bunch of dashboards that someone's already done for you, right? So they went and they looked at the data, they looked at the searches, they're like, all right, these are the good searches, these are useful searches, these are the dashboards for those searches, and they put it all together in a little folder, and they put it on Splunk Base and call it an app, right? So again, like, so you can create an app, your own custom app, and then once you make that app, you can ship it out to you can go give it to you can put it on Splunk Base and say, hey, just go download this, throw it into Splunk, and things will happen. Or you can do, pretty much however you want to distribute that. It's up to you. If you put it on Splunk Base, you can do that. So that's kind of why. So when people say, what is Splunk? Like especially like at Synergy, I got the question all the time. EG guys are here, so because we were like 3 booths down from them, right? And they're like, oh, so you're just like EG Innovations, and I'm like, no, we do what they do, but we're not similar because we're not a monitoring product. It isn't what we do. What we do is we're a platform, and kind of what my group has done has built a monitoring product that is similar in scope to these other companies, but we're not. Splunk is not a monitoring company. We're a platform you can build stuff on. A good example would be Uber Agent, right? So Helga came to our session last year, and he's like, "Man, this is really cool. Let me go build. I can build a solution to solve some of my customers' problems on top of Splunk, and I don't have to worry about coming up with a schema. I don't have to worry about a database. I don't have to worry about graphing. I don't have to worry about anything. All I need to do is worry about what I'm really good at, which is writing code to go get the data I want." So we're really kind of a platform that allows people to do that kind of stuff. But because of the way the platform is and how powerful it is, what we've done, our group specifically, is we've wrote solutions for Zen App and Zen Desktop and NetScaler, which allows us to build this stack story, which a lot of other companies have problems with, which is we can show you from the network layer all the way down to the UCS layer, all in one interface. And I can show you this at the master class, where we can kind of get this whole story all in one big thing with correlation. So I can show you your storage, but I can show you your storage with a user focus. I can show you your network from a user focus, not like, oh, well, there's my network appliance and I don't know what's going on with it, or I know it's not doing good, but I don't know who's impacted with that, because we can correlate that. I can easily make those associations. On top of that, we're agnostic. I don't have to pick a horse, right? I don't have to say, well, I'm only going to do Citrix, or I'm only going to do VMware, or I'm only going to do Citrix and VMware. Doesn't matter. You can do any hypervisor, OVM, KVM, Zen Server, Hyper-V, VMware. Doesn't matter. Doesn't matter what, Riverbed, NetScaler. I always get NetApp and NetScaler confused. So NetScaler, or you can be using CloudBridge, or you can use, it doesn't matter to me what you use. We can collect data from all those sources. We can put them in Splunk and correlate them. It doesn't matter if you're using XenDesktop 5 and XenDesktop 6, or going from XenDesktop 6.5 to XenDesktop 7. I can store all that data in one interface, give you the visibility for XenApp 5.0 and above, all in one interface. Your Windows environments, your Unix environments, all in one interface, all with correlation. Exchange, Active Directory, got all that. We can store all that data. We can do the correlation. Your business applications, we can kind of do all that as well. Put all that stuff in Splunk. And what you end up doing is you stop this narrow-minded focus on monitoring, which is okay, it's valuable, but then you take that monitoring, which is actually just a cost, and you take it to operational intelligence, which is a return on investment. Right? It's no longer, can I make sure stuff is up? It's, can I get value out of the data that's out there? And instead of Splunk costing you money, or your monitoring product costing you money, it's actually giving you money back. Okay, 2 more minutes? So from that perspective, I think that's one of the big plays that we have over all the other competitors, at least in this one little niche market. We do a lot more stuff outside of just Citrix and VMware. But anyway, any questions? We have a couple more minutes before we go. I can breathe now. I, for the record, wasn't nervous. So no questions? Sean? Oh. You just wanted to see it bigger? He likes it bigger. On that note...